Google DeepMind has just introduced two groundbreaking AI models, Gemini Robotics and Gemini Robotics ER, designed to take robotic intelligence to an entirely new level. These models can perceive their environment, understand human instructions in natural language, and generate actions, making robots far more capable and adapted than ever before. This marks a major leap in automation, pushing robots beyond rigid programming and into a more intuitive, instinctive way of interacting with the world. On March 12, 2025, Carolina Parada from Google DeepMind announced the launch of Gemini Robotics, a vision language action VLA model built on top of Gemini 2.0. While Gemini 2.0 was already considered a powerful AI for multimodal reasoning, handling text, images, audio, and video, it primarily processed digital information. In contrast, Gemini Robotics moves beyond digital reasoning and extends its capabilities to the physical world. It generates physical actions as output, meaning it can control a robot's movements and interactions with objects in real-world environment. DeepMind also unveiled Gemini Robotics ER, where ER stands for Embodied Reasoning. This model is designed to enhance a robot's spatial understanding, enabling it to grasp how objects exist in three-dimensional space, how they can be manipulated, and how to plan complex actions like picking up an object from the right angle or avoiding obstacles. This spatial intelligence is crucial for robots to function autonomously in unstructured environments such as homes, warehouses, and even public spaces. What sets Gemini Robotics apart? The introduction of Gemini Robotics and Gemini Robotics ER represents a paradigm shift in robotics. Here are the key aspects that make these models revolutionary. Number 1. Multimodal perception and natural language understanding. Gemini Robotics is a vision language action model, meaning it integrates visual data like camera feed, natural language inputs, spoken or written instructions, and action generation. This allows a user to give commands as if they were speaking to another person. Instead of requiring detailed programming, a user can simply say, "Pick up that book and place it on the shelf," and the robot will execute the task based on its understanding of the command and its surroundings. Number 2. Generalization across new tasks. Traditional robots are programmed for specific tasks and often struggle with anything they weren't explicitly trained for. Gemini Robotics, however, is designed for generalization, meaning it can handle new objects, environments, and instructions it hasn't encountered before. Google tested the model against a generalization benchmark, and it outperformed previous state-of-the-art robotics models by more than double, proving its ability to handle unseen scenarios. Number 3. Real-time adaptation to dynamic environments. One of the biggest challenges in robotics is dealing with unexpected changes. If an object is moved or knocked over, many robots would fail to complete their tasks. Gemini Robotics continuously monitors its environments and can replay in real time if circumstances change. This is particularly important in interactive settings where robots must adapt to human actions or shifting surroundings. Number 4. Fine motor control and dexterity. Another major limitation in robotics has been dexterity, the ability to handle objects delicately and precisely. Gemini Robotics has been demonstrated performing fine motor tasks such as folding origami, packing a snack into a Ziploc bag, grasping fragile objects without breaking them, turbing, and turning a doorknob. These are tasks that, until now, have been incredibly challenging for robotic systems. Google DeepMind has released video showcasing robotic arms controlled by Gemini Robotics, carefully manipulating objects, a crucial development for industries requiring precision, such as manufacturing and home assistance. Number 5. Embodied reasoning for spatial problem solving. Gemini Robotics ER is specifically designed for spatial intelligence. It understands how objects exist in physical space, determines the best way to grasp them, and plans movement accordingly. For example, if a robot needs to pick up a coffee mug by the handle, Gemini Robotics ER will analyze the best approach and execute it flawlessly. This embodied reasoning capability makes the robot more autonomous and efficient, reducing the need for human intervention. Now let's talk about the real-world applications and industry adoption. Google DeepMind is not just developing these models in isolation, they are actively working with leading robotics companies to integrate Gemini robotics into real-world robots. Partnerships with robotic leaders. Google has partnered with Aptronic, a company known for its humanoid robots, particularly the Apollo robot platform. Not only is Google collaborating with Aptronic, but they have also invested in the company, which has raised $350 million in funding last month. This strongly suggests that we might soon see humanoid robots powered by Gemini robotics in real-world applications. Other major robotics companies are also testing Gemini Robotics ER, including Boston Dynamics, famous for its agile robots like Spot and Atlas, developers of humanoid robots for warehouse automation, and Enhanced Tools, a robotic company focused on assistive robots. These collaborations mean that Gemini Robotics is being integrated into multiple robot types across different industries, accelerating real-world adoption. As robots become more autonomous, ensuring they operate safely and ethically is a top priority. Google is addressing this by introducing a new dataset called the Asimov dataset, inspired by Isaac Asimov's 3 Law of Robotics. This dataset is designed to improve semantic safety and embodied AI, ensuring robots understand and follow human ethical guidelines. Additionally, Google has been experimenting with a robot constitution, a framework of natural language rules that guide robots away from unsafe or unethical tasks. The Asimov dataset will help test and refine these safety measures, ensuring that Gemini-powered robots make morally sound decisions in real-world settings. The potential impact of Gemini robots is enormous. In the near future, we could see robotic assistants in homes that handle daily chores with ease, warehouse and industrial robots that adapt dynamically to changing environments, medical and caregiving robots capable of assisting the elderly or disabled with precision and safety, and humanoid robots in workplaces that interact naturally with human workers. One of the most exciting aspects is the ease of use. Unlike traditional robots that require extensive programming, Gemini-powered robots can be controlled through simple spoken commands. If needed, Gemini Robotics ER can also generate Python scripts for fine-tuning robotic behavior, making it versatile for both casual users and professional roboticists. Google DeepMind's Gemini Robotics and Gemini Robotics ER are a game changer in the field of robotics. With their ability to see, understand, and act in real-world environments, they bring us closer to robots that are genuinely helpful, adaptable, and safe. The partnership with Aptronic, Boston Dynamics, and other robotics companies indicate that these models will soon be tested in real-world applications, potentially transforming industries from logistics to healthcare. Meanwhile, the introduction of the Asimov dataset ensures that these AI-driven robots will operate ethically and responsibly. If you're passionate about robotics, this is definitely a moment to watch. The next few years could bring an entirely new era of intelligent, intuitive, and interactive robots into our everyday lives. And that's it. Thank you for watching this video. Also, don't forget to like and subscribe to our channel.